be greater than 0 and your x must be equal to a. So at this point, so these two conditions are satisfied this, and that is why the minimum point is going to be f prime of root 3 equals to 0, then f prime prime of root 3 is greater than 0. That's the first. Then for the maximum at x equals to minus root 3, then we'll have f prime of minus root 3, f prime of minus root 3 is equal to minus 6 root 3. This time around is less than 0. So hence the maximum point will be f prime of minus root 3, which is equal to 0, comma f prime prime of minus root 3 is less than 0. So this is the maximum point, because under the maximum, two conditions that must be dy dx is equal to 0. The 2, then you have d2y dx squared is less than 0 and your x equals to a. So these are the points. Now, being able to justify the stationary points, the minimum points, and the maximum points. Now, we can use the concept of maximum and minimum points to determine the maximum value. So it means that in determining the maximum value, it is very important that we know the concept of maximum and minimum point. That means the maximum and the minimum point have their usefulness in determining the maximum point. An example here is to justify the claim. Example 1 says that find the greatest product of two numbers whose sum is 12. So here we are asked to determine the maximum value. So we can use the concept of minimum and maximum point to determine the maximum value. The question says find the greatest products, that is the maximum value of two numbers whose sum. So before the sum of two numbers can be 12 automatically, that means solution. Let the first number be x. Then the second number will be 12 minus x, and that can be justified by saying x plus 12 minus x will definitely give us 12, and so that means the first number is x, the second number is this. Then the product means x multiplied by x, 12 minus x, and that will definitely give us 12x minus 2x squared. I said 2x squared, x squared rather. 12x minus x squared. That's what we're going to have. So let's assume that our y is 12x minus x squared. So we are to find the y, the x. So we differentiate this. We are going to have 12 minus 2x. At stationary points, the y dx is equal to 0, and at that point our maximum value is determined. So automatically then we have 12 minus 2x will definitely give us 0. So automatically we have 2x equals to 12. Then dividing both sides by 2, we are now going to have our x to be equal to 6. So this is the maximum value. So find the greatest product of two numbers whose sum is this. So automatically the maximum value will be at that point where the value of x is 6. Let's consider the application of differentiation in velocity and acceleration. It should be noted that velocity is the rate of change of displacement, while acceleration is the rate of change of velocity. So mathematically, if we differentiate the displacement, then with respect to x, or with respect to time t rather, we'll have our velocity. So what are we saying? If x is distance or displacement, because velocity is a vector quantity. So if x is displacement, so automatically dx dt will definitely be our v, which is known as your velocity. So dx dt is our velocity. So if we still move on to differentiate, that means if you differentiate displacement twice, then we'll have our acceleration. Or if we differentiate velocity, we will have our acceleration. What am I saying? So if I say dv dt, we will definitely have our acceleration, which is a. So that is the relationship between this parameter. If x is the displacement, if you differentiate this displacement with time, we have our velocity v. If you differentiate the velocity with respect to t, at time t, differentiate your velocity, then we'll have our acceleration. So that is why velocity can be defined as the rate of change of displacement, while acceleration is the rate of change of velocity. So now let's see this example to justify the application of differentiation in velocity and displacement. The example says that the motion of a particle from O is described by the equation. This equation is given to us, where s is the distance in meters and t is the time in seconds. Find the acceleration of the particle when it is momentarily at rest. There are some fundamental terms here that has mathematical application, especially differentiation. Now we are talking about a parameter known as acceleration here, and we know that if we are to determine our acceleration, that means we will differentiate our velocity. So we have a scenario like this, where you have a distance that is given to you, s, to be 2/3 t cubed minus 17t squared over 2, then plus 21t. This is our distance. So we can differentiate the distance. If we differentiate distance with respect to time, we get our velocity. So if I say ds dt, that will be my velocity. My velocity will be ds dt, which is equal to here. So if you have to differentiate this, you bring this on here, it cancels this. So if you are differentiating this, it will be this times this, like bringing this one here, 3 times 2/3 that is already here, t raised to power 3, you subtract 1 from it, minus, bring this one also here, 2 times 17/2, subtract 1 from it, plus, this is 1 raised to power 1, 1 times this is 21, t1 minus 1. So that is a simple way of differentiating what you have there. Then that will now be 3 can cancel 3, then we'll have 2t, 3 minus 1, 2, so 2t squared minus, this can cancel this, minus 1, here, then we have 17t, then this, that becomes 20 plus 21t 0, and anything raised to power 0 is 1, so automatically this equation becomes t squared, 2t squared minus 17t plus 21. So this is our velocity. But our interest now, we can factorize this. Because if you have this now, we are going to have 42. That would definitely be 42 t squared. What are the factor of 42? That will definitely give us the one in the middle. Let me say 42. So we have 2, that's 21, 3, 7, and 7. So automatically 1. So that will be 7, 6 as a factor. Then we also have 14, 3 as a factor. Which one will give us minus 17? The one that will give us minus 17 should definitely be this one. 14 minus 3 will give us minus 17. So automatically, what we do here is to say 2t squared minus 14t minus 3t plus 21. So we can bring this one, bracket this like this is common here, 2t into t minus 7. Then this one will be minus 3 into t minus 7. So at the end I will have t minus 7 to 2t minus 3, which is equal to, which is this. So that means we have ds dt to be equal to this. ds dt is equal to this. And remember that the question, find the acceleration of the particle when it is momentarily at rest. So when it's momentarily at rest, when it is momentarily at rest, that point ds dt will be equal to 0. When it is momentarily at rest, ds dt is equal to 0. And to take it from ds dt, which is equal to t minus 7 to t minus 3. So at ds dt equals to 0, then I will have t minus 7 to t minus 3 equal to 0, which implies that t minus 7 is equal to 0, or 2t minus 3 equal to 0. Then t will definitely be equals to 7 here, or 2t equals to 3, which implies that your t will definitely be 3 over 2. So you have to, this t seconds, this seconds, because it's measured in seconds. Now, the question now is find the acceleration. This here, at this point, we have our velocity. So if you differentiate this further, then we